All right, we're gonna do another one, like a dy dx equals, I don't know, I'm gonna do a y plus 1, okay? And here I'm giving you a differential equation that's dependent only on my y value. All right, so if I start plugging in y values, it doesn't matter what x is, okay? It's only what y is. So if I start with y equals 0, then I'm going to have slopes of 1. So y equals 0 is along the x-axis. I'm going to draw little tiny lines with slopes of 1, okay? If I go up to y equals 2, y equals 1, my slope will then be 2, right? If I plug in 1 for y, my slopes will be 2, so a little bit steeper. Okay, if I go up here to bigger y values, they're just going to get steeper yet, and it's going to get really hard to draw these little tiny little dashy lines, and they look really clumsy. Where is the slope 0? Well, this is 0 when y equals -1, right? So when y equals -1, I'm going to have those little horizontal slopes. Okay, what was I going to say? If I plug in something like -2 for y, I'll have slopes of -1, which is going to look more like this. Okay. If I were to solve this diffie-q, I'd have 1 over y plus 1 dy equals dx. If I integrate both sides, I get natural log absolute value of y plus 1 is equal to x plus c. If I exponentiate both sides, I get e to that equals e to that. And I get y plus 1 equals c e to the x. I get y is equal to c e to the x minus 1. Okay, the only reason I'm solving these differential equations right now is just to make some sort of connection between these two things. Do you guys see if I said to go through, if I asked you to draw the solution curve that goes through the point 0, 0, here's 0, 0. Okay, the flow of this field is it's sweeping me up this way. And then do you see how this kind of levels out? You don't want to make connections. You just want to follow the flow of the field. The flow of the field would go this way. Okay, do you see how this is an exponential function shifted down 1 unit now? Because I followed the flow of the field. So the whole reason that the old dudes started making slope fields is because there are some times where there's a differential equation that you can't solve. So for example, if I gave you guys dy dx equals x plus y, this is not something I can do separation of variables on. If you take a course in diffie-qs, you'll look into what you can do with this. But the old dudes felt like, okay, I can't solve this. I can't do separation of variables because I'm not allowed to have dy dx minus a y. I can't divide by a y because that'll screw up my middle term. So what are you going to do? Well, what they decided to do is draw a slope field. All right, now this slope field depends on both x and the y coordinate. If I plug in 0, 0, I get a value of 0. If I plug in 0, 1, I have a value of 1. If I plug in 0, 2, a value of 2. 0, 3, a value of 3. If I plug in -1, 0, I have a value of -1. -2, 0, -2. Where else is the slope going to be 1? Well, I'm sorry, where else is the slope going to be 0? It's where x and y are opposites. So I can have x's and y's opposites along this line. Okay, if you were to plug in, let's say -1, 1, you get 0, -2, 2, you get 0, or 1, -1, you get 0, and so on. And then you could calculate slopes along the way. So if I plug in the point 0, 1, I get a slope of 1. Sorry, that's 1, 0. 2, 0 would be a slope of 2. 3, 0 is a slope of 3, and so on. If I plug in the point 1, 1, I get a slope of 2. Now, it's really hard to get an accurate slope field for more than just a couple little dashy lines. And if I wish I had my computer here to generate this for you. You can do this on Desmos. You guys can try to graph on Desmos. You might have to Google how to do a differential equation. I wish I was there to do WinPlot with you guys, but if you fill in these little slopey lines, and I'm doing a terrible job because I'm rushing, but you're going to end up being able to see a potential solution curve through your slope field. So that's what the old guys wanted to accomplish by graphing these things. So like if I know that this is my differential equation and I can't solve it, and I know that my curve goes through the point, let's say 0, 1 again. Okay, let's say that that's here. I can then figure out the shape of my solution and help me estimate some values. So do you guys see I'm not connecting little dashy lines? I'm just kind of following the flow of the field. It's a very sort of hippie, not mathy thing to do, but that's what those little slopes, they're pointing you in a direction. All right, let's start there.